Assalamualaikum warahmatullahi wabarakatuh. My name is Nety Kurniaty. I am a lecturer from the Faculty of Science, Universitas Islam Bandung. Today, I would like to present my research paper with title Synthesis of Tetrapeptide with Antioxidant Activity using Solid Phase Peptide Synthesis as an alternative of natural product isolation from pork. Our team member are myself, Nety Kurniaty, MSc, and Ms. Umu Rosidah, MPD, Mr. Anand Suparman, MS, Ms. Resi Yulianti, S.Farm, Ms. Siti Sophia, S.Farm, and Ms. Wanda Melinda Baharudin. Let's start with introduction. Synthesis of organic compound is one method to obtain chemical compounds that have certain activities other than through isolation method from natural materials. The advantages of synthesis of organic compounds are that they can increase the efficiency of effectiveness of a process to obtain compounds, shorten time, save solvents, replace natural materials that were difficult to obtain, replace natural materials from prohibited such as not halal sources, and increase the bioactivity of the resulting compound. Isolation of natural material compounds that have biological activities has been done extensively. However, the availability of the compound is very limited, or the raw material is difficult to obtain because they are available in remote location. In addition, there are many chemical compounds that have biological activity but are originated from animals, for example from pigs, which cannot be consumed by Muslims. Previous research has shown that pork has antioxidant activity from tetrapeptide, which is serine, leucine, tyrosin, alanine, tyrosine, alanine, and tyrosine, leucine, tyrosine, alanine. However, that peptides originated from pork are forbidden for Muslims. Another high antioxidant activity is also found from tetrapeptide glycine, alanine, tryptophan, alanine, that is isolated from the fish Sardinella aurita from Atlantic Ocean that's hard to catch. Therefore, alternatives should be sought to obtain peptide compounds with the same sequence of amino acid that has biological activity in the form of the same antioxidants, even tend to be better. So the synthesis of peptides known as peptidomimetics. So what is the peptidomimetics? Peptidomimetic is a field of chemistry that aims to improve the biological and mechanical properties of native proteins, to increase bioavailability, biostability, bioefficiency, and bioselectivity. And also the small protein-like molecules designed to mimic a peptide typically arise from structural modification of an existing peptide to enhance its stability and biological activity. And this research aimed to develop a genetic metathesis-driven process to synthesize those tetrapeptides and modify some of the amino acid residue. The synthesis of three tetrapeptides, which is serine, leucine, tyrosine, alanine as tetrapeptide 1, and tyrosine, leucine, tyrosine, alanine as tetrapeptide 2, and the last one is glycine, alanine, tetrapeptide leucine. Modification from the natural product glycine, alanine, tryptophan, alanine as tetrapeptide 3 are carried out by the method of synthesis of solid phase peptide synthesis and call it SPPS due to the shorter synthesis time compared to the use of liquid phases, and purification also can be done in the final stage only. Hence, it can be concluded that the SPPS method is easier and faster. And then tetrapeptide synthesis products obtained are tested for purity using reverse phase high performance liquid chromatography RT-HPLC, and then characterized using a mass spectrometer and tested its antioxidant activity using the DPPH method. And the synthesis of these tetrapeptide compounds is something that has never been done before. This research is expected to provide information on new tetrapeptide compounds with antioxidant potential, as well as now know the role of amino acid against antioxidant activity. This is the material that I use from for my research, and this is the tools, and this is the procedure scheme. We start with conditioning the tube and preparing the resin beds, and then do the coupling amino acid, and then capping the resin, epoxy protection, chloranil test, and until the tetrapeptides constructed, and then doing the cleavage of resin, then evaporation, analyzing with HPLC, and characterization using mass spectrophotometer, and then the last one thing is doing the antioxidant activity test using the DPPH method, and we got the tetrapeptides with antioxidant activities. And this is the procedure. I want the detail of the procedure, but this is the condition of the coupling reaction, and this is the condition for the FMOC, the protection, and then the cleavage, the resin from the tetrapeptide using TFA, and after that doing the chloranil test to make sure that all the tetrapeptide is already constructed, and then doing the evaporation process for analyzing with HPLC using this condition, and then characterization with mass spectrophotometer, and the last thing is antioxidant activity analysis with the PPH method with this condition. And for result and discussion, after the research, the three tetrapeptides, serine, leucine, tyrosine, alanine, as tetrapeptide 1, and tyrosine, leucine, tyrosine, alanine as tetrapeptide 2, and then the last one is glycine, alanine, tryptophan, leucine, had been successfully synthesized using SPPS method, using the resin chlorotrithyl chloride, and with FMOC strategy with the coupling reagent HPTU and HOPT. On the synthesis of tetrapeptide compounds, the first amino acid trapped to resin was alanine and leucine for the last one, and alanine amino acid had methyl side groups unprotected in C-terminals, and the amino acid groups in N-terminals protected by FMOC temporary protecting group. The extension of the peptide chain was done from the direction of C-terminal to N-terminal. And the coupling of amino acid in resins to chlorotrithyl chloride began by dissolving amino acid with TCM and DPA, and this is the following reason of the procedures. And based on the reaction that occurs, the first reaction stage was through the base acid reaction between FMOC alanine and an alkaline DPA is as a reagent that form carboxy ions. And after 4 amino acid coupling, we got the brownish yellow gem tetrapeptides constructed. That much, yeah, not too much. So it's not too much for the rendezvous. And the crude of tetrapeptides analyzed using SPLC with this condition, and then this is the result, the diagram of SPLC for second tetrapeptide, and this is for the third tetrapeptide. And then for the mass spectrophotometer result, it we can say that it confirmed that those tetrapeptide is being constructed well. Okay, this is the result of the mass spectrophotometer, this one also. And for antioxidant activity analysis, we found that those tetrapeptides has a weak antioxidant activity because the IC50 is still more than 150 microgram per milliliters. Yeah, this is the solvent composition, and this is the result, and this is the graph of antioxidant activity. And for the conclusion, that from the research we can conclude that 3 tetrapeptides compounds has been successfully synthesized, confirmed with the mass spectrophotometer, and then for the antioxidant activity, I can conclude that those tetrapeptides have weak antioxidant activity with the IC50 more than 150 micrograms per milliliters. This is reference that I use, and then we would like to thank the LPPM grant of Universitas Bandung 2019 for funding this research. Thank you. Okay, that's all for me. Assalamualaikum warahmatullahi wabarakatuh.